In this video, I'm going to work out number 10 on page 21 in your packet. So the first thing we would do is factor and simplify, and you can see that I already gave it to you in factored form. So now I just need to simplify anything that can or will simplify. But you'll notice that nothing actually cancels out. So this is the most simplified answer. Well, since nothing canceled out, that means we do not have any wholes. All right. The only time you have wholes, remember, is if you can set the canceled out portion equal to 0, and then that would help you get your whole, but we do not have that here. So now we're going to look at our vertical asymptote. So to get the vertical asymptote, we take our denominators and we set them equal to 0. So we have x plus 4 equals 0, and we have x minus 1 equals 0. So if I solve for x, I would get x equals negative 4, and x equals positive 1. So I'm going to do a little mental math there, right, to get that. So I'm not showing all of my steps. But I have two asymptotes, vertical asymptotes. One of them is at negative 4. So I'm going to draw that dotted line there. And I have another one at positive 1. Now I'm going to look at my horizontal asymptote. All right, so for horizontal asymptote, we have to figure out, is it top heavy, bottom heavy, or equally heavy? So this is fully factored, so I'm just going to look at this original. And my exponents, my leading degrees on both of these are 2 and 2. Well, that's equally heavy. So it says to get the horizontal asymptote, we're going to say y equals the leading coefficient over the leading coefficient. And in this case, it's 1x squared, 1x squared. So that's just 1 over 1, which is 1. So y is equal to 1. So I go to y equals 1, and I draw a dotted line at y equals 1. So that gives me both my horizontal and my vertical asymptotes. Now I need my x-intercept. So to get the x-intercept, it says to set the numerator equal to 0. So I'm going to have x minus 7 equals 0, and x plus 1 equals 0. So a little mental math here, x is equal to positive 7. So 7, 0 is an x-intercept. And then x would equal negative 1. So negative 1, 0 is also an x-intercept. So I'm going to go ahead and plot those 2 points. So I have 7, 0 right here, and negative 1, 0 right here. All right. Now to get the y-intercept, I'm going to substitute 0 in for x. So 0 minus 7 times 0 plus 1 over 0 plus 4, and then 0 minus 1. All right, so when I do that, I get approximately 1.75. All right, if I put that in my calculator, so my y-intercept is 0 and then 1.75, or it was 7/4. Okay, this was 7/4 if you wanted the actual fraction. Okay, but the decimal's fine. So I'm going to go 0 and then up 1.75. So I'm going to plot that point. All right. Now, I still need some additional points because unfortunately this really isn't enough to see what's going on with my picture, all right, or my graph. So I'm going to go to my table, excuse me, and I'm going to type n over d, and it doesn't matter if I type the original or the factored, it doesn't really matter. So I'm just going to type in the original. All right. And I'm just going to see if I can find some whole numbers. Okay, so I have negative 1, 0. I already have that point. I have negative 3, negative 5. 1, 2, 3, 4, 5. So right here. I have negative 5, positive 8. So right here. Bunches of fractions. So let me go the other way to see if I can see anything. 7, 0, I already have that. So I have a whole bunch of decimals and all that kind of stuff, right? All right, well, the decimals don't really matter as much. I mean, I can plot them if I really want to get really super precise with my graph, but this is really enough. So what I would do is in this region, remember it's like regions, right? Region, region, region. So everything has to kind of alternate. So think about what happens with this region. I know it has to approach these asymptotes, so this one would approach up to the right, and then it would approach down to the left. Now again, this may be a little sharper or whatever, but because I'm not getting exact points, but this kind of gives me a rough idea of what the graph would look like. Now on this far right side region, this point is on the bottom right here in this little corner. So again, that's going to curve towards the asymptotes. So I can kind of see that right there. Now the middle region is the part that gets you a little thrown off. So think about what I said about the zigzag or the alternating. This is high and this is low. So if this is high, low, high, low. So this right here would curve down towards this asymptote because high and then low, and then this is going to kind of curve back up through these 2 points and up towards this asymptote. So notice when I'm talking about the zigzag, it's high, low, low. And that gives us at least a decent estimate of what our graph would look like.